In this question, they've said the diagram shows a water container in the form of an inverted pyramid, which is such that when the height of the water level is 8 centimeters, the surface of the water is a square of side half h centimeters. Express the volume of water in the container in terms of h. The volume of a pyramid having a base area a and vertical height h is 1 over 3 times ah. So we have this inverted tank, right? So we have this opening over here, which the tank has the shape of a pyramid. And the water also occupies the shape of a pyramid. Now, the base is a square with side length half h centimeters and the height is simply h centimeters. So, if we had to calculate the volume, we can say, well, the volume for this guy is equal to, 1 over 3 times the base area times the height. And we know that the base area, since we have a square, the base area is simply the side squared, right? So the side times itself. So what we have is a base area over here, 1 over 3 times half h squared, that's the side of the square, the base area times the height. So the volume is simply equal to 1 over 3 times 1 over 4 h squared times h. So we can say that the volume is equal to 1 over 12 h cube, and that's your volume in terms of h, 1 over 12 h cube. So that's your answer for part 1. Now we figured out what the volume is in terms of h. So we know that V is equal to 1 over 12 h cube. Now in the next part, they're saying find the rate in, so water is steadily dripping into the container at a constant rate of 20 cm cube per minute. So what that means is that the volume is changing by 20 cm cube per minute. So the change in volume with respect to the change in time, the rate of change of volume is 20 cm cube per minute. So we can say that dV over dt, which represents the change in volume with respect to time, is equal to 20. That's a constant value. Find the rate in centimeters per minute at which the water level is rising when the height of the water level is 10 centimeters. Find the rate at which the water level is rising. What that means is that they want to know the change in height, the rate at which water level is rising, the change in height with respect to time. So we have to figure out what dH over dt is when h is equal to 10 centimeters. So this is the information that we have. Now, let's try to take our unknown, which is dH over dt. That's what we have to find when h is equal to 10. So dH over dt. And we have information about dV over dt. Is there some way we can relate dH over dt and dV over dt? Well, yes, we can. We can do this using the chain rule. If they've given us dV over dt, we know that dV over dt times dH over dV will give us dH over dt. So we have dH over here in the numerator. So we're going to need dH over here. So what we have is dH. And we need to get rid of dV. So this is just dH over dV. So in terms of the chain rule, we can express dH over dt as the change in volume with respect to time times the change in height with respect to volume. Now we already have an expression of V in terms of H. We know over here that volume is equal to 1 over 12 h cube, which means that if I take the derivative of volume with respect to height, we have to find dH over dV, but let's find dV over dH. If we find dV over dH, what we get is we multiply this constant by the power and then decrease the power by 1, right? So we know this. So this is going to be 3 times 1 over 12 h squared. So that's 1 over 4 h squared. And when h is equal to 10, we can say that the change in volume with respect to height is simply 1 over 4 times 10 squared. So that's 25. So now we have our value for dV over dH. Now dH over dV is simply the reciprocal of this. dH over dV is simply the reciprocal of this. So we can say that dH over dV is simply 1 over 25 when h is equal to 10. And dV over dt is a constant. That's just 20. So this is 20 times 1 over 25. So we can say that dH over dt is simply 20 times 1 over 25 when h is 10. So therefore dH over dt is equal to 0.8 centimeters per minute. So that's the rate at which the water level is rising when h is equal to 10 centimeters. That's your answer.